the class. Today we are going to learn about the partial differential equations. We will see what a differential equation is and when a differential equation is called to be a partial or an ordinary differential equation. Start. Partial differential equation is an equation that arises most of the time in our real life equation, and how we can say it can be found out that is given equation is a partial differential equation. So here we are saying that when the number of independent variables in the equation is 2 or more, then the equation that will come into the picture is a partial differential equation. Let's talk about the dependent and independent variable. Let us say y is a function of x. Here x is independent and y is depending upon x. So if I will frame a differential equation from there, then what type of things will come into the picture is I will get a function of x, y and the derivative of y with respect to x, and whatever is coming into the picture as this whole function, this will be called as an ordinary differential equation. But if the number of independent variables are 2 or more, for example, if I say z is a function of x and t, so here I can differentiate z with respect to x, or I can differentiate z with respect to t, and the equation that is formed with help of x, t, z and the derivatives results in a partial differential equation. So let's talk about the definition. Here we are saying an equation containing one or more partial derivatives of an unknown function of 2 or more independent variables is known as a partial differential equation. Here in most of the examples we are looking at, we are having del z by del x, del z by del y. It means we are considering z as a function of x and y. Here x and y are the independent variables and z is a variable which is depending on x and y. I think most of the examples are of this type, and here in the fourth one I can say I am having the derivative del u by del x, del u by del y and del u by del z. So u is considered as a function of x, y and z. That's why we are getting the derivative of u with respect to x, y as well as z. Now the next most important concept is how we will find out the order of a partial differential equation. So here we have the order of a partial differential equation is the order of the highest partial derivative occurring in the partial differential equation. So as we know, a partial differential equation involves the derivatives. So if we talk about the highest order, so it will give me the order of the whole PDE. For example, here if we see in the first equation, we are having first order derivative with respect to x as well as y. What is the order of this whole PDE? The order is 1. About the second one, here this is first order derivative, this is third order derivative, here again first. So what is the order? Highest partial derivative is 3 here. The next one, again we have the first order because both derivatives are of first order. This one again of order 1. This is, here I am getting second order derivative. So the order is 2. Here we are getting del z by del x, del z by del y. So order is still 1. So here we are saying equation number 5 is of order 2, equation number 2 is of order 3 and all others are of order 1. So you have understood. The next most concept is how to find out degree of a partial differential equation. Now we know about the order. If we talk about the degree of a PDE or the partial differential equation, it is we have to look upon the highest order derivative and its power. But we have to see that the equation must be rationalized, that it is made free from radicals and fractions. The first one, if we see, in the first example, we are having del z by del x, del z by del y, no power of these. So order is 1 and degree is 1. For the second one, if we talk about order, we have written 3. Now this is the highest order derivative. Is it having any power? No. So the degree is 1. The next one, order is 1. What about the degree? Also 1. This one again of order and degree 1, 1 because we are having only first order derivative with power of 1. Now for the fifth one, if I will see, here we are getting the second order derivative. Now what about its power? Is it 1 or 2? Because here we are getting 1 by 2, so it's not free from the powers or the radicals. What I will do is I will squaring both the side. I will get del z by del x, del 2z by del x square whole power 2. is equal to 1 plus del z by del y. And now I will be able to see that order is 2 because of the second order derivative, and its power is also 2. So this is what we are saying, order is 2 and degree is 2. The last one, here the order is 1 but the degree is 2. Why? Because they are having a power of 2, right? So this is what we are saying, equation number 1, 2, 3 and 4 are of degree 1, while equation number 5 and 6 are of second degree. This is what we have observed. Now the next most important thing in learning of the partial differential equation is that which type of partial differential equation is that we are dealing with. So till now we have talked about order and degree. Now if we talk about an equation is linear or not, we are saying an equation is said to be linear if the dependent variable and the partial derivatives are only in first degree and are not multiplied together. We are talking about z as a function of xy. So dependent variables are, we have one dependent variable z, and what are the partial derivatives? Del z by del x and del z by del y. So if these three things are not multiplied together and they are of first degree, means they must appear with the power of 1, then it is said to be linear. And if it is not linear, then we have another category and we are calling it as a non-linear partial differential. Let's see the first one. Here we are having separate del z by del x and del z by del y, so it is linear. The second one, here we are getting del z by del x, but it is with the power of 2. Here we are saying they should be of first degree, so it is not linear. Third one, here I am getting a product z and del z by del x, so it is again not a linear one. Next one, it is linear because we are not getting a product of the z or any of the derivative of it, so it is linear. We have rationalized and we have seen that del 2z by del x square is coming with the power of 2, so again it is not linear. And here it is also not linear. Here we are saying only equation number 1 and 4 are linear and others are non-linear. So now what we are going to see is the nomenclatures or the notations we are going to follow in this course is that in case we are having two independent variables as x and y, and we are saying z is depending upon x and y, then following are the notations we are using. P, small p is del z by del x, q del z by del y, r del 2z by del x square, s del 2z by del x del y, and t is del 2z by del y square. So be sure to note it down because we are going to use it in the coming lecture. Here we have learned that the classification of PDE can be done as linear and non-linear, but if I dive deep into it, then we are not saying it is only linear and non-linear, but a linear to non-linear is a whole path that if it is not linear, it could be semi-linear, it could be quasi-linear, and if not, then it is non-linear. Here we have a brief description that a first order equation, now specifically we are talking about first order equation. This is a PDE of first order because here we are saying z is existing, and now you can see I have used p and q, del z by del x and del z by del y. So it is said to be linear if it is linear in p, q and z and having this form. This is the form of equation where capital P, Q, capital R and capital S are the function of x or y only, and they are being multiplied by P, Q and Z and should be written in this form. If we are getting this form, we are saying it is linear equation. Here we have some examples. P into function of xy, Q into function of xy is equal to Z into function of xy plus some extra things. Let's see another example. Here if it is nothing, it means it is 1p, 1q, 1z plus xy, so it is also linear, right? So these are both first order linear partial differential equations, and we can say they are linear in p, q and z because p is in power of 1, q with the power of 1 and z with the power of 1, and they are not multiplied anywhere with z. Next is semi-linear equation. Now we are calling it as a semi-linear equation if the equation is of this form. This thing is same, but here I can observe that instead of what we written in the linear one is rxy into z plus sxy. Now here we have removed the condition and we are saying it should be r of xyz, means anything should come here which is a function of xy or right. So if we have equation of this form, it is said to be semi-linear. Here are some examples. E into xy, q into x square y, and here we are getting only a single term and it could be anything in x, y and z. Okay, this is a semi-linear equation. Here the another one, yp plus xq is equal to this right hand side. Again a semi-linear equation, and we can say these are first order semi-linear partial differential equation, and they are linear in p and q but not in z, because here we have z that could appear in any form. Next one is quasi-linear, when we are taking the comparison of xy from these p and q. Now you can see we are having function of xyz into p, function of xyz into q, and here xyz function. So we have learned about linear, semi-linear, quasi-linear. And what if we talk about nonlinear? So if the partial differential equation is not coming under any of the three above type, then we are calling it as nonlinear. For example, here you can observe p square and q square. Now in all the terms we have p into something, q into something, but here we are getting it to the power of 2. So it is nonlinear. Here you can say p and q are multiplied together. Here again I am getting p square and q square. That's the reason they are nonlinear. Now this is the brief summary. You can note it down. Let's have some MCQ. What is the type of this partial differential equation? It's p, q, and it is multiplied by x, y and z. So it is quasi-linear. It is a quasi-linear. Let's look for another one. It's p into something, q into something, and here I am getting z into something plus another one. It is a linear PDE, right? So let's stop here, and in the next class we are going to learn about formation of partial differential equations, how we are going to create the PDEs from the given relations.